Look, in hypothesis testing, we never accept a null hypothesis because hypothesis testing is basically asymmetrical, right? So you're only testing if there's enough evidence to reject the null. You're not proving it's true. So think of it like a courtroom, right? So your null would be the defendant is innocent. Your alternative is that the defendant is guilty. If there's not enough evidence, you don't say innocent, you say not guilty. So you fail to reject the null, but you don't say it's true. So instead, you say, hey, reject the null when p is less than alpha. You fail to reject it when p is greater than alpha. Basically, the wording is very important because it keeps it honest. You're not proving that the null is correct. You're just saying, hey, look, the data didn't give you enough evidence to conclude otherwise. Just basically, we're not in statistics, we're not proving anything to be true or false. It's not something that's 100%. We're just making decisions based on probabilities and uncertainty. Probabilities are never going to be perfect 100% that this is true, or there's always this element of uncertainty. So we set up this framework to detect evidence against the null. We're not trying to verify it, we're just trying to detect how much evidence is there. So what we can do is we can reject the null if your sample data is very unlikely under the null, or fail to reject it if your sample data isn't strong enough to rule out the null. But you can't responsibly say, hey, I accept the null as true. Because in most cases, you didn't prove the null, you just didn't have strong enough evidence to dismiss it. So one more example, in medicine or pharmaceuticals, you could say, hey, look, this is the null. The drug has no effect, or in this case, the drug does have an effect, right? So if you have a p-value of 0.15, so you fail to reject the null. But the point I'm trying to make here, you don't accept uh, the alternative. You just say, hey, look, it doesn't mean that the drug has no effect. It might, but we didn't gather enough data to detect it. The drug could still work. Maybe the study was underpowered. Maybe the effect size is small, but accepting the null would imply certainty, which, look, this test never provides. It doesn't provide certainty. It just provides evidence or lack of evidence. That's all I'm trying to say. That's why we never use the word accept. And when we get into something like type 1 errors, type 2 errors, you have type 1, which is you have a false positive, and then you have type 2, which is false negative. So in a type 2, when you fail to reject the null, that's what happens. When your alternative is actually true, that's what happens with a type 2 error. So if you accept the null, you're basically risking understating the possibility of this type 2 error. So that's why it really matters. You don't want to accept the null. There's this possibility of a type 2 error. So if you say, hey, I failed to reject the null, you preserve that uncertainty and acknowledge that your test may have missed something. And that's why statistics and uh, data science and um, machine learning, well, not so much machine learning, results of machine learning outcomes all are iterative because you may need to retest certain assumptions. We never want to conclude, hey, look, this is something for sure. I'm going to accept this. You should always provide evidence or lack of evidence based on the p-value and how it relates to alpha. And again, I do apologize for this. Let's get this clear one more time. If the p is less than alpha, you reject it, else you fail to reject it. What's a good way to memorize this? If the p is low, reject that h sub o. If the p is low, which is less than 0.05, reject H sub O. It kind of rhymes. Um, so then the opposite would be you failed to reject it.